Okay, when thinking about the energy of a system, as you've just seen in the thermodynamics section, you've got your various results of an exothermic reaction, should we say, which we'll do in red, which will give a negative change in energy because it's giving it out, so negative, and that's actually a delta H, which is negative. Whereas an endothermic reaction will be positive, and that's just a little abbreviation for negative, that's just VE, and that'll be a positive delta H value. An equation that takes into account not only this but also the disorder of the system, which the disorder is known as entropy. So we'll write this down, entropy, and that's basically the sort of how many times things bump into each other. So if you've got a system which has a lot of entropy, then there's going to be a lot of collisions per second, and that's helped by things like increasing the kinetic energy, say by heating it up a little bit. So anyway, that's given the symbol delta S. So don't forget delta means change, and these were the enthalpy, it's delta H. And don't forget to put the noughts because that means it's at standard conditions. So anyway, we end up with the final equation, which is delta G, standard conditions, equals delta H, the enthalpy, minus temperature times the change in entropy. And so I put in standard conditions on all of those. And delta is just a symbol for change, just to remind you. Okay, so if the result of this, whatever calculations of all the numbers that you do, which we're not actually going to cover here, but you need to know what the outcome means. If delta G is greater than 0, so we'll say greater than 0, the reaction isn't going to go easily, it's not feasible. It's not impossible, but it just isn't going to go without some pretty impressive encouragement. However, delta G is less than or equal to 0, it is going to be feasible and it will go. That doesn't necessarily also mean that it will definitely go without question. For example, if you light a match and put it near gas, that is actually what's setting the gas off into the explosion. The gas will technically explode, but it needs something to get it there, and that's basically getting over the activation energy barrier, which is what the match is doing for the system.